Hi there, this video is going to cover the chapter review for the chapter 5 test from the Brown book, the Trig one, but just the first part that is the non-calculator part. And then we'll follow up later in the week with the calculator part, although the review PDF does include both, but they're marked as to which one's which. So these sections that are highlighted on the book on this part of the test are really just 5.1 to 5.3. 5.4 is more on the second part. And we started with 5.1, which started with just the initial angles, your quadrant angles that were like 0, 90, 180, 270, and then back around to 360. We learned how to graph those. You won't have to graph on the test like you did on the quiz. But you do need to know coterminal angles. So remember, to find coterminal angles, we can add and subtract 360 from our angle to get either a positive coterminal or a negative coterminal. And those angles will have the same value of the trig functions. Then we did from degree, minute, second to decimal degree. So something like 100 degrees, 15 minutes, and 25 seconds. And we said we could take the minutes, divide it by 60, and the seconds, divide it by 3,600, and then add those together. So 15 divided by 60 is 0.25, and 25 divided by 3,600 is 0.00694 repeated. So add that to the 0.25, and that plus the 100, and I'd get 100.256944, and so on. And then just pay attention to what it tells you to round to. We also went back the other way, so decimal degree to degree, minute, second. So let's say I wanted to take something like 125.4572 and convert it to decimal degree, or to degree, minute, second. The whole number part becomes the degree. And then I take the decimal, 0.4572, and multiply it first by 60. And the whole number part of that is the minutes. And then I take the decimal part of that, the 0.432, and I multiply it times 60 again. So 0.432 times 60. And I get 25.92. So if it says to round to the nearest tenth, I'd round it to 0.9. If it says to keep the decimal, I would keep it as 25.92. You will only have the lockdown calculator again for this one, or a 4-function calculator. So you wouldn't be able to use any conversion features on your, like a graphing utility or a scientific. Just keep that in mind. Then 5.2 is where we got introduced into the trig functions using coordinate points. So you got given an x and a y, and from there we would draw out our graph. So I would go the x value, the y value, and I would make it a triangle, putting theta in the corner. The hypotenuse of that triangle is the radius. So we later talked about that we could use SOHCAHTOA, but for these in the beginning, we use the radius. Sine is y over r, cosine is x over r, tangent is y over x, and then cosecant was the reciprocal of sine, so r over y, secant is r over x, and tangent is x over y. We make sure every time that we simplify any kind of fractions that can be simplified, and we rationalize any square roots that might be in the bottom. In this section were also our Pythagorean identities. So this is sine squared of theta plus cosine squared of theta equals 1. This is tangent squared of theta plus 1 equals secant squared of theta. And 1 plus cotangent squared theta equals cosecant squared theta. And we use these if we were given one value and you wanted to find another. So let's say you're given the cotangent and you want to find the cosecant, or you're given the tangent and when you want to find the secant, or you're given like sine and you want to find, let's say, secant, then I would use sine to find cosine and then flip it to get the reciprocal function. So you'll see examples like that in the PDF of the chapter review. Okay, then 5.3, we talked more about the trig functions. We brought the word SOHCAHTOA back from geometry, which is sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. We also talked about our 30, 60, 90, and our 45, 45, 90 triangles. So there's two ways to look at these. One, as in general triangles with any side lengths. The ratio would be A root 3 and 2A for a 30, 60, 90 triangle. And for a 45, 45, 90 triangle, which would be an isosceles right triangle, it would be A, and A root 2. But as soon as we give these triangles a radius of 1, which is what happens when we put them in that circle, we now have fixed side lengths. The A would be the 1. So if this is 30, 60, 90 inside with a radius of 1, the A is 1. This is root 3. Opposite the 60 is root 3, and opposite the 90 is 2. And in a 45, 45, 90 triangle, opposite the 45s are 1s, and opposite the 90 is root 2. And this led us to finding the sine, the cosine, the tangent, the secant, the cosecant, and the cotangent of angles like 30 degrees, 60 degrees, 45 degrees, 90 degrees, 180, the ones that are on your unit circle like that were on the coordinate grid, those kind of things. But you're not going to be asked straightforward those questions, because those you can pretty much gather from like the chart that you made in the homework or anything like that. You've got to learn how to pull those from like a coterminal angle, for example. So in these it says, find the trig functions of special angles, and we're going to keep these exact because we won't have a calculator. For example, coterminals are negative angles. So obviously 450 is not in these special right triangles. What I do know is if I take 450 and I subtract 360 from it, I get 90 degrees. So 90 degrees is my coordinate point, that's 0, 1. My radius is also 1 because I went up 1. So I can find the sine of 90, the cosine of 90, the tangent of 90, the cosecant of 90, the secant of 90, and the cotangent of 90 using y over r or x over r. So sine would be the y, 1 over 1 is 1. Cosine is the x, 0 over 1 is 0. Tangent is the y over the x. 1 over 0 is undefined. And then we do the reciprocals. So flip 1, it's still 1. Flip 0, it's now undefined. And flip undefined, and it's 0. So we can do that with coterminal angles that are quadrant angles. They literally lie on your x-axis or your y-axis. Or you can look at something like B, where negative 300, I would want to find the coterminal by adding 360. And I get 60 degrees. So 60 degrees, I can use my 30, 60, really sloppy triangle, 30, 60, 90, 1, root 3, and 2. And I'm using 60 degrees, which is at the top. So if I did sine, I can use opposite, which is root 3, over hypotenuse, which is 2. Cosine, adjacent, which is 1, over hypotenuse, which is 2. Tangent, opposite, over adjacent, which is root 3. And then flip them. So cosecant would be 2 over root 3, which gets rationalized to 2 root 3 over 3. Secant, 2 over 1, which is 2. And cotangent would be 1 over root 3, which gets rationalized to root 3 over 3. So we can do this with any angle around our unit circle. Let's say I had 495 instead of 450. If I subtract from it 360, I end up with 135 degrees, right? 135 degrees is in my second quadrant. I'd find the reference angle, which is the distance from that angle to the x-axis. So remember our reference angles can be found in the first quadrant. They equal. So this little theta prime is your reference angle. They equal each other. So if it's 30 degrees, reference angle is 30 degrees. 60 degrees, 60 degrees. In the second quadrant, we do 180 minus theta. So that would be this case. If this angle is in the second quadrant, 135, I would do 180 minus 135, and I'd end up with 45 degrees. So the reference angle there is 45 degrees. I would find all of my trig values based on a 45, 45, 90 triangle. But then I'd want to look where it's originally located, and that's in that quadrant 2. And all students take calculus tells me that my sign would be positive. So I'd have a positive sine, and I'd have a positive cosecant, but the rest would be negative. Negative cosine, negative secant, negative tangent, negative cotangent. So if I were to finish this out, sine would be 1 over root 2, which gets rationalized to root 2 over 2. Cosine would be 1 over root 2, which gets rationalized to root 2 over 2, but it would be negative. Tangent would be 1 over 1, but it'd be negative. And then we'd flip. 1 over root 2 would just be root 2. This would also be root 2, but it'd be negative, and this would be negative 1. So that would be all the trig functions of 495. Your test is only going to ask you for one trig function. Just be prepared to be asked any of them. They could be a sine, cosine, tangent, or they could be the reciprocal functions. Okay, finishing out your reference angles. If the angle is in the third quadrant, then we do the angle minus 180. And if it's in the third quadrant, we do 360 minus the angle. So if I had something like 200, that's third quadrant, I'd do 200 minus 180, and that would be 20 degrees for my reference angle. So for the part of the test without the calculator, you will only get reference angles that fall in your special angle range, which is the 30, the 45, the 60, the 90, and then you can find your trig values from there. Okay, so then the reverse is finding theta. So remember that this is when we're doing the inverse. I'm giving you the value and you're going to give me the angle. And I know that it's different because I'm missing theta for each of these. So it's not like I'm asking, this one's missing it. It's not like I'm asking for the sine of an angle. I'm saying find the angle if the sine is negative root 2 over 2. And you're also given the interval of 0 to 360. So we're talking the full circle. So when I look at sine and it's giving to you as negative root 2 over 2, the first thing I would do is figure out where is sine negative. And sine is negative in the third and the fourth quadrants. So I know the answers to this question are going to come from those quadrants. Then the second thing I want to think about is my special right triangles, right? So remember 30, 60, 90, 1, root 3 and 2, 45, 45, 90. Are 1, 1, and root 2. So the only triangle that has a root 2 is the 45, 45, 90 triangle. So when I look at this one, and you're trying to figure out which one would be root 2 over 2, there's no side length that is 2, which means this was rationalized. This started as 1 over root 2 and then got rationalized into root 2 over 2. So now I'm looking for opposite being 1 and hypotenuse being 2. And that's either of the 45 degree angles, and it doesn't matter which one you pick. So let's say that our reference angle is 45 degrees, but I need it to be in the third quadrant and I need it to be in the fourth quadrant. So in the third quadrant, I'm going to do 180 plus 45, which is 225. And in the fourth quadrant, I'm going to do 360 minus 45, which is 315. And then those are the two angle answers that I'll give. When you type this answer on Canvas, there's no spaces and there's no degree measurement, and it will tell you to put them in order of least to greatest. So it would be 225, 315. Okay, looking at B now. B says cosine of theta is root 3 over 2. So again, first figure out what quadrants we're talking about. Cosine is positive in the first quadrant and in the fourth quadrant. The root 3 comes from the triangle on the left, the 30, 60, 91. Cosine is adjacent over hypotenuse. Adjacent being root 3 would be here, and hypotenuse would be 2, which means we're looking at the 30 degree angle. Because it is positive, 30 degrees is in the first quadrant. That's one of my answers. And then I have to do 360 minus 30 to get 330, which is the second answer. Go to cotangent theta equals negative root 3. So if it's cotangent of theta, then that means tangent of theta is also negative, and it's the reciprocal. So it'd be negative 1 over root 3. I don't have to rationalize it because I'm going to use my triangles. But what I do know from this is that tangent, students take calculus again, tangent is negative in the second quadrant and the fourth quadrant. So I have a root 3, which means I'm going to use the triangle on the left. Tangent is opposite and adjacent. So where 1 is opposite and root 3 is adjacent is the 30-degree angle. But that's not one of my answers because it's in the first quadrant. I have to go to second quadrant, which means 180 minus the 30, and that's 150. That's one answer. And then it's in the fourth quadrant, which means 360 minus 50. Sorry, minus 30, which is 330. And that's the second answer. All right, last up is secant of theta is 2 root 3 over 3. So that tells me cosine is the reciprocal of this. This is rationalized, so if you catch it, you can save yourself a little bit of work, but if you don't, then flip it, re-rationalize it, and then simplify it, and I get root 3 over 2. So root 3 again means I'm back to the triangle on the left. Cosine would be adjacent over hypotenuse. So which angle has the side adjacent? Root 3 and the hypotenuse of 2. We're back at 30 degrees. So this is 30 degrees. It's positive. Cosine is positive in the first quadrant and in the fourth quadrant. So I keep the 30, and then in the fourth quadrant I'd be 360 minus 30, which is 330. So that covers everything that's on your non-calculator portion, which is the first part of the test on Wednesday. So you're going to want to submit these notes. Make sure you submit your review notes. To the assignment on Canvas. And then use the remaining time to work on your review. So when you open up the PDF, you'll see at the top it says that highlighted in yellow are the part 2 with the calculator. So you can save that part and just do the other questions. Focus on the non-calculator part for now. So on that first page, number 19, second page, 28 through 31 is calculator based. 34 and 35, 39 and 40 are calculator based. Don't miss this one at the top. You do need to do that. That's your Pythagorean Identities one. Skip. And the last page, it's just 4, 6, 7, and 8 that you need to do. 10 and 12 you can save for the calculator part review. Guys, have a fantastic day. Don't forget to submit your notes, and I will see you soon.